Yes, so dear student, I Rakesh Jain from Gyanviyar University. Today I am going to teach you about the feedback amplifier benefits. In previous lecture, I have already been taught you that what is the feedback amplifier, how many kinds of feedback, like there are two kind of feedback. Feedback means some part of the output is again fed back to the input so as to change again the output. That is known as feedback. The feedback are of two types, positive feedback and negative feedback. The negative feedback generally employs for the amplifier and the positive feedback is generally employs for the oscillator circuitry. Negative feedback generally of four types: voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. In previous lecture, we have already been seen the difference between those four kind of feedback. There is some structure to denote them, right? Noise, non-linearity, distortion will be reduced, voltage gain will be reduced. In case of series feedback, the input impedance will be increased like in voltage series and current series, the input impedance will be increased, and in voltage shunt and current shunt, the input impedance will be decreased. In case of voltage amplifier, the output impedance is reduced. For example, in case of voltage series and voltage shunt, the output impedance is reduced, whereas in current series and current shunt, the output impedance is increased. So there are certain differences between those kind of amplifiers which we saw yesterday. And also there are some benefits of the negative voltage amplifier, negative feedback, that voltage gain is reduced. And yesterday we saw how the voltage gain is reduced. Now today, one more benefit we will see, that how in the negative feedback amplifiers, how in the with the help of negative feedback, the input impedance will be increased. So just we begin our journey on this MS Paint file. Yes. Yes, so here we will start. I just write down the name of myself. Now we will start here. Okay, so today the first topic is how with the help of negative feedback the input impedance will be increased. So I just write down the name of the title, how negative feedback improve the input impedance. Okay, now we will see how the negative feedback will improve the input impedance. So first of all, let's us consider a voltage series feedback. Okay, so I am going to draw the basic block of a voltage series feedback. So this is a forward gain of that voltage, any voltage series feedback, that is denoted by A, and this beta denotes you the negative feedback. Okay, so here I am going to write down beta to show that this is a feedback. Okay, beta is the feedback and A is the forward gain of that circuit. Okay, here one resistor is connected, that is load resistor, from where we will find out the output voltage V0. This load resistor is, let's suppose, denoted by RL. Okay, now this beta feedback network is connected here and here. Okay, the input AC signal is applied to the as an input, so it is denoted by V input. V input. So this is a basic block representation of a voltage series feedback. So let's suppose we have a voltage series feedback. Now we have to prove that the negative feedback improve the input impedance. Now see very carefully. This output signal V0 when passed from this feedback network beta, definitely it will generate a signal that is beta V0. And this beta V0 will apply to the input again. So now the input is not only the V input, it is actually V input minus beta V0. I use the term minus because it is a negative feedback. So here we have to write down. Now here I have to write down V input minus beta V. Okay, here beta V0. V input minus beta V0. I decrease. Okay, V input minus beta V0. If you are able to see, I just write down V input here. This is minus beta V0. Okay, I just write down here again. So the input will be actually V input, that is V in minus beta V0. This will be applied. So what will be the next output? The net output is actually A multiplied by V in minus beta V0. So here we will find the actual output V0 as multiplication of the forward amplifier gain A with the input. What is the input? Input is A V in minus beta V0. This term we have already been seen yesterday. Okay, in previous lecture I showed. So V output is equal to A V in minus beta V0. Okay. So what is the input? Input is V in minus beta V0. Okay. Now to prove that the input impedance is increased, I use a terminology. Just to see this terminology, I can use V input as, for example, let's suppose I have X. So can I write down X as X minus X plus Y? Sorry, can I write down Y as X minus X plus Y? Yes, I can write down. I can write down because I know that from again X to X will be cancelled out and only Y will be remaining. So like this terminology, I just write down the input V input as V input minus beta V0 plus beta V0. I can write down like this one. Okay. And actually, what is the input? Input is V in minus beta V0. Okay. V in minus beta V0 is the input here. Okay. Now, I know that the input can be known as the input which is denoted here as V input minus beta V0. It is nothing. It is actually this input. What is the exact input? Exact input is V input minus beta V0. So this is what, this is actually the input voltage, and voltage can be from the Ohm's law. We know that the voltage is equal to current multiplied by resistance. Let's suppose the input current is I. I is the input current. I for current and subscript I for input. So II is the input current. So whenever this current will be multiplied by the resistance, here we use the term impedance. So I use the input impedance, let's suppose Z input. Okay. So this input V in minus beta V0 is nothing. It is actually Z in minus II. Okay. So let's suppose this is equation number 1. This is equation number 2. I just write down that the input voltage, which is actually not V input, it is actually V input minus beta V0. Okay. So this input voltage is equal to voltage. And what is the voltage? Voltage is equal to current multiplied by impedance or current multiplied by resistance from the Ohm's law. So let's suppose the current is II, that is input current, and the impedance is Z input, or we can say ZI, input impedance. Okay. So now see, in this terminology, V input is equal to V input minus beta V0 plus beta V0, because I have already been told you that Y can be written as Y plus X minus X. So beta V0 to beta V0 again cancel out, and only V in is equal to V in. Okay. So here in this terminology, just put V input is equal to V input. See very carefully, and if you have any question after the completing of this topic, you will ask to me. V input minus beta V0 plus beta. Till now I cannot do anything. But now at place of this V0, I write down the V0 from equation number 1. From equation number 1. Okay, so what is V0? That is A V in minus A beta V0. Or A is at outside, A is at outside, V in minus beta V0. From equation number 1, I just write down this. Okay, now see, V input is equal to, from the first term and the second term, what is common? Now see with this green color. In the first term, V input minus beta V0, and after the plus, again V input minus beta V0 is there. So if I take them as a common term from both the side, then what will happen? V input minus beta V0 is common. V in minus beta V0 is common. Okay, now what will remaining? From the first green color first side, 1 will be remaining, and from the second side, A beta will be there. 1 will be remaining, and now this is A beta. Okay. Now, what is this V in minus beta V0? Now see from equation number 2, with this green color I am going to show you. From this equation number 2, what is V input minus beta V0? V input minus beta V0 is nothing, it is input impedance multiplied by input current. So actually this V input is equal to, in place of V in minus beta V0, I just write down Z input II. Z input II. Okay. And the remaining term is as it is, that is 1 plus A beta. A and this is beta. Okay. Now see very carefully. I just move this II. See from this brown color, I'm going to show you. Move this II at the left hand side. So what will happen? At the left hand side, I have V input. Now this will be divided by II. That is equal to Z input. That is impedance of input multiply by 1 plus A beta. Now see very carefully. What is V input upon II? V upon I is what? Again the impedance or resistance if only resistive element are there, but we consider impedance instead of resistance. So this is a new impedance. V input upon II is what? New impedance. So I just write down as ZI. The actual input impedance is nothing. It is the input impedance multiplied by 1 plus A beta. This new input impedance is input impedance multiplied by 1 plus A beta. Whenever any term will be multiplied by something, then it will definitely increase. We consider this one now. Let only y is there. And if I say now y is equal, y is nothing. Y is replaced by xy. Then definitely we consider that it will be increase. Okay. So we prove that the input impedance, that is Z input, see from this orange color I am going to show you. So at the starting, we have to write down that let us consider a voltage series as we find that this Z input is not only Z input, it is actually Z input multiplied by 1 plus A beta. This is new input impedance, that is ZI. So ZI will be increased. So ZI will be increased, and this was our topic, that how the uh, voltage series feedback, or we can say how the negative feedback, because voltage series is also a kind of negative feedback. So how's the negative feedback improve the input impedance? So now it is proved that the input impedance will be input impedance of a network can be improved by applying the negative feedback. Okay, so this is the proof of how negative feedback improve the input impedance. Now, if you have any queries, if you have any question, and if you understand this, then type in message box, okay, we understand. If not, then type in message box if you have a question. Type in message box, okay, I understand. If you are able to hear me, then type in message box, okay, I understand. Yes, Vishal Kumar understand. And this one. Rahul, Pritam, Vivek, Himanshu, Lal Babu, all other If you understand, then okay, very good. So I think you all understand that how the input impedance is improved. Now we will see that how the voltage gain is stabilized. How the voltage gain is stabilized. How the stabilization of the gain occurs in negative feedback amplifier. So now see this one. Okay. Now I am going to remove this slide and we'll start with a new slide. Okay. Now see. Wait. Yes. Now we see that how the negative feedback will improve, yeah, will stabilize the gain. How the negative feedback will stabilize the gain. So I just write down the name of the new topic. That how how negative feedback improve or stabilize the gain. Okay, how the negative feedback stabilized the gain. So we will see how the negative feedback stabilize the case. Again, let us consider any negative feedback case. Generally, we employ the voltage series feedback. So let us consider a voltage series feedback. So again, the forward gain of that uh, voltage series feedback network is, let's suppose, A, and the feedback gain, let's suppose, is denoted by beta as usual. Okay, now see very carefully. Okay, let's suppose the output load resistance is denoted by RL, from where we will find out the voltage, output voltage V0. Now this beta is connected with here. This feedback network is connected with the output side so as to apply the some part of the output at the input side again. And this is the input, V input, which is applied at the input side. Okay, so this is a voltage series feedback. Now, when this output voltage V0 passes from the beta network, it will be, that is feedback network, it will be beta V0 again. And the same kind of things will be again and again in front of you. Okay. Now, the new input will be V input minus beta V0, which is actually applied at the input side. This is same as the previous two cases. Okay. So now what is the new output? The new output for this, first of all, we just see what is the gain of the feedback. Without the feedback, the gain is only A. And with the feedback, we know that the gain will be reduced. That is A divided by 1 plus A beta, which we have already been proved yesterday lecture. Once again, we have to reach up to that derivation, then we will see how the gain will be stabilized. Okay. So V0 is what? V0 is actually A multiplied by the net input. And what is the net input? Net input is V input minus beta V0 due to the feedback applied, negative feedback applied. So beta is from this V0 is equal to AV in minus A beta V0. Okay. So from this, the A beta V0 will be moved to the left hand side. So V0 will be common. So we will find out 1 plus A beta in the bracket. We have already been seen these derivation till now, whatever I shown you in screen yesterday. Now, with the help of this, we will find out V0 is equal to A divided by A is the without feedback term. A divided by 1 plus A beta. This is new gain. Gain is what? Output upon input. Because this gain comes, so output upon input is V0 upon V input. So from the right hand side, the V input will be moved to the left hand side. So now this is the new gain. Gain is denoted by A. What gain? Feedback gain. So AF is actually without feedback gain A divided by something. It means the gain will be reduced. We have already been proved that the gain will be reduced. Now we have to see how it will be stabilized. Okay. So this is what, this is the derivation of how the gain is reduced in case of voltage series feedback, or in negative feedback, how negative feedback reduces the gain. So this is the proof of how negative feedback reduces the gain. Now we will see how it will, the gain will be stabilized. So now finally we find out that the gain AF, means the gain with feedback, is actually the gain with without feedback, that is A divided by 1 plus A beta. It means it is reduced. Now let us consider this A beta is greater than 1. Let's suppose the A beta term is greater than 1. Okay. If this is greater than 1, then we can neglect this 1. Okay. So AF will be equal to A divided by, because A beta is much more greater than 1. So we can neglect the 1 from the denominator side. So only 1 A beta will be remaining. What I want to say, see with this black color, I say that this A beta term is very greater compared with this one. So we can neglect this one term. Okay. I can remove this black side so you will understand. Okay. So what will happen? This A to A will be cancelled out and only 1 upon beta will be there. It means the gain AF, which is a gain of with feedback, the gain with feedback will be equal to 1 upon beta. And beta is what? Beta is a feedback network. And generally in feedback network, we connect resistors. Passive elements we only connect. Okay, resistors. And all the resistors have their fixed value like 10 kilo ohm, 2 kilo ohm, 5 kilo ohm, like this one. It means beta is approximately fixed quantity. Beta is approximately a fixed quantity. Because beta is fixed, it means the gain is also will be fixed. It means the gain is stabilized. The gain will be stabilized. Stabilized means stable at a particular value. So the gain will be stabilized because generally the AF will be actually equal to 1 upon beta, and beta is a feedback network. In feedback network, generally we employ the passive element whose value are fixed. Because of the fixed value of those passive elements, we can say the gain will be stabilized. Okay. Now we will see again after this. So the gain will be stabilized. I just write down this terminology here. Due to dependency only on feedback network, which uses or which employs passive element like resistor, so gain will be stabilized. Okay. Due to dependency only on feedback network, which employs passive element like resistor, so the gain will be stabilized. Okay. Okay. Now we understand that how the gain will be stabilized. Now we will see that without the gain, without the feedback, the variation in the gain, and with feedback, the variation in the gain. Okay. What will be the impact over there? So we will just see that the impact, what is the relation between the variation in without feedback with variation in with feedback. Okay. Now see this one. So right now here I will show you. So I just remove this Wait for a while. Okay. So now I uh, move this term. This term is here. Okay. The remaining term. This is the proof of the stabilization. The gain will be stabilized. Now I am showing you how the negative feedback. What is the relationship between the variation in without feedback and the variation in gain with feedback. Okay. So now see. Okay. So with feedback, I know that AF will be equal to the AF will be equal to I prove that this AF will be equal to I just denote this equation as equation number 1. So AF is equal to A upon 1 beta. Okay. Now what I am going to do, differentiate the LHS and RHS with respect to A. Differentiate the LHS and RHS with respect to A. I just write out differentiate with respect to gain without gain, that is A. Without gain is what? Without feedback. Without feedback the gain is A. With feedback the gain is AF. Okay, remember this. So now differentiate the LHS and RHS with respect to negative feedback without gain, that is A. Okay. So the left hand side will be DAF upon, this is the denotation of differentiation of any term, dx by dy, like this one. So DAF by whom with respect to you are going to differentiate with respect to A. So DAF upon DA. Now here there are two terms, x divided by y. So how we can differentiate y? I just write down how we can differentiate if a terminology are like x divided by y. So first we differentiate the y. I just write down y differentiation of x minus x differentiation of y divided by y square. This is the rule of differentiation of two changeable term, two differentiable term arranged in a divide format. Okay. So here a and 1 plus a beta, there are two terms. So y means 1 plus a beta. So I just write down 1 plus a beta dot differentiation of x is what? A. this a is now x here from that formula, and this 1 plus a beta is my y. Okay, so y dot dx, so y is 1 plus a beta dot dx means da is what? 1, because we are going to differentiate with respect to a itself. So differentiation of a with respect to a is 1, minus x is what? A. Then dot differentiation of y is what? 1 plus a beta. So the differentiation of 1 is 0. The differentiation of a beta with respect to a, so only beta will be remaining. So a beta is remaining. Okay, if you have any query, you will ask me after the completion of this. Within 1 minute we will complete this. So divided by y square, so y is my 1 plus a beta, so 1 plus a beta square. So now this a beta to a beta will be cancelled out, only 1 will be remaining. So DAF, see very carefully, DAF upon DA will be equal to 1 divided by 1 plus A beta square. This is equation number 2. Now divide this equation number 2 with respect to equation number 1. I'm going to write down here. Divide the equation number 2 by equation number 1. Okay. No, first just move this A, then we will do this. Wait for a while. Okay. I just write down. No, this is not equation number 2. I again move a little bit change I will do. I just move this DA at the right hand side. Okay. Once again, I am copy and paste this. And what change I am going to make? I just move this DA term from the left hand side to the right hand side. Okay. This is equation number 2. Okay. Let's suppose this is equation number 2. Now I am going to write down that divide equation number 2 by equation number 1. Shambhu, you do your work, what I told you, okay? Divide equation 2 by equation 1. So what will happen? Just space. I just remove this formula terminology and shift the whole as here. Okay. Now, so now when I divide this term, so DAF will be divided by AF. Okay. And at the right hand side, this DA divided by 1 plus A beta square is the equation number second term. When it is divided by equation number 1, so at the equation number 1, A is there. So A will be here and this 1 plus A beta will be at the upper side. This will be here and this 1 plus A beta will be moved at the upper side. So what will happen? This 1 plus A beta 2 square will be cancelled out. So finally we will find out that DAF upon AF. What is this DAF upon AF? This is the variation in negative feedback gain using feedback is equal to what we will find out at the right hand side. DA upon A is there. DA is present. A is also there. And also it is multiplied by 1 upon 1 plus A beta. I just separate the terms, nothing else. See with this black color I am showing you. DA is here, A is here. So DA upon A and this 1 plus A beta is also here. So DA upon A dot 1 upon 1 plus A beta. Now see very carefully. This is the final conclusion. This DAF upon AF is what? This is, I just write down this term. What is this DAF upon AF? So this DAF upon AF is, see very carefully. The DAF upon AF is variation in the gain of negative feedback. Variation in the gain of negative feedback is equal to, what is this dA upon A? This dA upon A is the variation of in the gain without feedback, because A variation in gain without feedback. Now see very carefully. Variation in the gain of negative feedback is equal to variation in the gain without feedback divide by 1 plus A beta. It means it is decreases. It means what should be the title of this third term? This third term which we studied today, that prove that variation in gain of negative feedback is less than variation in gain without feedback. Okay, so this is the proof of this. So that previously I do not write down the name of the topic. Now I am going to write down the name of topic. If there will be any question related to prove that the variation in a negative feedback is less than variation in gain without feedback. So the variation in gain of negative feedback is equal to variation in gain of the negative without feedback divided by something. It means it is less. So it is the proof of variation in gain of negative feedback is less than variation in gain without feedback. So this is the third. So we have proved that the input impedance will be increased. We have proved that the gain will be stabilized. We prove that variation is less compared to without feedback case, and we prove that the voltage gain is reduced. So till now we prove 4 terms. These 4 terms are the 4 benefits of the negative feedback, which we have already been seeing. Okay. Now the remaining benefits we will see in next lectures. So I hope you understand. So I Rakesh Jain from Gyanware University wants to say you thanks for watching the video. Thank you. Thank you very much.